Hello everyone, welcome back to my channel. Today I would like to introduce one of my compact tabletop layouts that I designed. Although it is small enough to fit on a table, it combines both a railway system and a smart road traffic system into one interactive layout. As you can see, the layout includes railway tracks, roads, traffic lights, and the miniature vehicles you've seen in my previous videos. Recently, I completed a brand new Windows application that allows me to control the entire layout from a computer. In this video, I'll give you a brief introduction to the software and demonstrate some of its main features. Let's get started. The software was developed using Microsoft Visual Studio 2022. I launched the application in debug mode. First, you'll see the splash screen while the program starts. Once the software has loaded, it automatically begins communicating with the wireless controller. This small device is my wireless router. Its display shows the active communication details. At startup, it displays my channel name. When you connect a new device to the router for the first time, you simply press this button once. The router automatically detects the device and stores its unique address in its internal memory, so there's no need to pair it again. The router is connected directly to the computer and provides two-way wireless communication between the software and every vehicle on the layout. The bidirectional communication allows the computer to send commands to the vehicles while also receiving status information such as battery level and connection status. Here are the two vehicles. The first is the city bus which is currently under development. I'll be making a separate video dedicated to this vehicle soon. The second vehicle is the ambulance, which many of you will already recognize from my previous videos. Previously, this vehicle used my first generation control board which I call the P1 board. That version could only be controlled using an infrared remote control. Today I'm demonstrating my latest P3 control board. The P3 board supports both infrared remote control and computer control simultaneously, making it a significant upgrade over the previous version. Before controlling the vehicles, let's take a quick look at the layout editor. The software contains several menus including File, Edit, Road, and other editing tools. Here, you can place straight road sections, curved sections, intersections, and railway tracks. Each section automatically snaps into position, making it easy to design complex layouts. You can also flip and rotate individual road pieces to create almost any configuration. The software isn't limited to roads, it can also control railway systems, making it a complete traffic management platform. The software supports both left and right railway turnouts. Each turnout can be operated manually or automatically. In manual mode, I simply click the turnout and the railway switches immediately change direction. In automatic mode, the software can change the turnout automatically after a program delay or based on sensor events. This makes it possible to create fully automated railway or road traffic operations. The layout supports multiple sensor types. The first type is the reed sensor. A small magnet is installed inside each vehicle, while a reed switch is mounted underneath the road. When the vehicle passes over the sensor, the magnet activates the reed switch and the software immediately changes the sensor indicator from gray to green. This allows the software to know the exact position of each vehicle. The second sensor type is an infrared sensor. Infrared sensors can be used to stop a vehicle, start it again, reduce its speed, or perform other custom functions depending on the programmed operation. Both sensor types can be controlled manually or integrated into fully automatic operation. Now, let's connect the vehicles to the software. The ambulance is already powered on. The bus currently has no battery installed, so it is powered through the serial interface for now. To connect the wireless router, I open the settings menu and select serial port. COM4 is connected to the router, so I'll connect to that port. After a few seconds, the software automatically detects every active vehicle. Each detected vehicle receives its own dedicated control panel. The city bus uses a blue control panel, while the ambulance will display an orange control panel shortly. No manual setup is required. The vehicle's address is already stored in the router's memory because it was paired previously by pressing the router button. As soon as a vehicle powers on, it announces itself to the router, which forwards the information to the software. This automatic discovery process creates a reliable two-way communication link between the software and every vehicle. Each vehicle has its own control panel with dedicated function buttons. These include headlights, horn, and other functions. For example, when I press the headlights button, the headlights immediately switch on. Pressing the button again switches them off. The same applies to the siren and horn functions. The currently active function is highlighted, making it easy to see the vehicle's current status. The software also monitors battery status. If the battery indicator is red, the vehicle should be recharged soon. When fully charged, the indicator changes to green. This makes it easy to monitor every vehicle without checking it manually. Now let's switch to automatic mode. The software asks for confirmation. Once enabled, manual controls are disabled because the software now operates the vehicles automatically. Instead of pressing buttons yourself, you can create sequences of commands, assign delays, and allow the software to control the vehicles completely on its own. This enables realistic traffic movement and fully automated railway operation. I won't demonstrate the complete automation in this video because it deserves a separate video of its own. For now, I'll switch back to manual mode. This was a brief introduction to my smart traffic and railway control software. In future videos, I'll demonstrate many more features including fully automatic traffic control, intelligent railway operations, scheduling sensors, wireless communication, and many new vehicles. If you enjoyed this video, please consider liking it, subscribing to the channel, and leaving a comment below. Thank you very much for watching. Have a great day, and I'll see you in the next video.